Hello everyone. Welcome to today's session on real numbers. So in real numbers, we are going to look at the fundamental theorem of arithmetic. Okay. So before we get into the fundamental theorem of arithmetic, let's revisit our number system. Okay. You guys would have learned the number system in your lower classes, but let's do a quick review of that. So number system, right? So real numbers can basically be divided into two parts, right? So that's rational numbers and irrational numbers. Okay, so real numbers can be divided into rational and irrational. In rational, right? So we can say the rational numbers can be like integers. So integers are denoted by capital Z, right? And integers, the subset of integers, right? So let's say rational numbers can be integers and integers can be like whole numbers. And whole numbers can be into natural numbers. So natural numbers is denoted by capital N, the whole numbers with capital W, and integers with capital Z, and rational numbers and irrational numbers. So this is our number system, right? So what are natural numbers? So the natural number set is from 1, 2, 3, and so on. So this is natural numbers. And what are the whole numbers? Whole numbers is natural numbers along with 0 is whole numbers. Understood? So natural numbers set along with 0 is whole numbers. And then integers. Integers will have both positive and negative values. Like, for example, -3, -2, -1, 0, 1, 2, 3, and so on. So these are integers. And then what are the real numbers, right? Sorry, the rational numbers. The rational numbers, we can say rational numbers, or let's say in the form P by Q, where Q is not equal to 0. These are rational numbers. So rational numbers are in the form P by Q, where Q, the denominator, is not 0. So that is rational numbers. So from this, can I say that the natural numbers is a subset of whole numbers, right? And whole numbers is a subset of integers, and integers is a subset of rational numbers. Understood? And this set, the rational numbers and irrational number all together is a real number. That's a number system. Okay. So natural numbers as a subset of, the whole numbers is a subset. Okay, hold on. So basically this is reverse, right? The subset means, see, I'll tell you. So let's say this is natural numbers. And then on top of that, you will have whole numbers. On top of this, you will have integers. On top of this, you will have rational numbers. That means n is a subset of W. Means all the natural numbers are present in the whole numbers, and whole numbers are subset of integers. All whole numbers are present in what is this? Z is what? Integers. And all integers are present in the rational numbers. Okay. This is how we denote it. So hope you are clear with the number system, right? So rational and irrational numbers. Rational numbers can be integers, whole numbers, and natural numbers. Okay, let's move on. Let's move on to a prime factor of numbers. So if you have any number that can be factored, that can be written into the factors of prime numbers, that's where we can end it. For example, you have like 64. Okay, 64 I have. So how I can write 64? Can I write this as 2 into 32, right? And then 2 into 2 into 16. Can I? Right? Hope you guys are following. And then 2 into 2 into 8. So 2 into 2 into 2 into 2 into 4. And then 2 into 2 into 2 into 2 into 2 into 2. So that means 64 I can write as 1, 2, 3, 4, 5, 6 in the powers of 2 power 6, where 2 is a prime number, right? For example, I have 45, right? So 45, if I want to write into the prime factors, will it go by 2? No. 3? Yes, right? So 3 into 15 times, right? So 3 into 15 I can further write as 3 into 5. So that means 3 square into 5. So 45 I can write as 3 square into 5, where 3 and 5 both are prime numbers. So any number you can write as the prime factors, the multiples of prime factors. For example, let's look at this number, right? Let's write any one number. I'll take some example here, right? Let's take this, a bigger number, 455. Okay, this number, if I write with 2, it will not go. With 3, I'm not sure. 3 ones, 3 fives, no. With 5, it will go. So 5 into 5 nines, 45, 5 ones, right? So 5 into 91 is 13 sevens, right? So 7 into 13. 13 sevens, 91. So if you look at here, so 455, I'm able to write in the factors of, in the multiples of prime numbers, like 5 into 7 into 13. So 5, 7, 13, all are prime numbers. So this is where we can end. So if you take any number, you can write that number into the multiples of prime numbers. That is called prime factors of a number. So hope you understand how to divide that number into prime factors. So what are the prime numbers? 2, 3, 5. The numbers which are divisible by 1 or the number itself. The prime numbers are the numbers which are divisible by 1 or the number itself. Like for example, if you take 13, 13 do not have any factors, right? So it has to be 13 itself is the factor, 13 ones, right? Like that, any number which do not have factors and divisible by 1 or the number itself is a prime number. So if we look at the prime numbers like between 1 and 20, for example, right? So the prime numbers are, 2, 3, 5, 7, 9 is not a prime number because it 3 is 9. So it has factors. So 11, then 13, 15 is not a prime number because it has factors. 5 threes are 3 fives. So then 17 and so on. You understood, right? So if we can write any number, we can write into prime factors like this. Okay, now let's look at the main theorem, that is the fundamental theorem of arithmetic. So what fundamental theorem of arithmetic states is every composite number, in fact, any number can be expressed or factorized. So that's what we looked at previously, right? How to factorize the number. So every composite number can be factorized as a product of primes. That's what we did earlier, right? And this factorization is unique, apart from the order in which the prime factors occur. Yeah. So it's basically what we just learned here. is stated as fundamental theorem of arithmetic. What is that? Any composite number can be expressed or factorized into prime numbers. Understood? For example, let's take any another example. Okay, so 3825. Let's do this. 3825. This is a composite number, any number. So as I have 5, I'll start with 5. 5 ones, 5 into 5 sevens, 35, then 32, 5 6 30, then I have 25. 5 5s 25. So I can write this number as 5 into 765. Then again, I'll do with 5. 5 ones, then 26. 5 fives, then I have 5 threes. So 153. So I can write this as 5 into 5 into, now I need to do with 3. 3 fives and 3 ones. Understood? Now 5 into 5 into 3 into, can I do with 3? Yes. 3 into 3 ones 3, 3 sevens 21. So 17 is a prime number which we do not have factors. So 3825 I can write as 5 square into 3 square into 17. These are the prime factors, and you can have 5 or 3 in any order. It can be 3 square into 5 square into 17. So the order doesn't matter. That's what it specifies. Every composite number can be expressed as a product of primes, and this factorization is unique because if you divide this number 5, 3, and 17, these are the prime numbers you will get. It can be in any order, but that is a unique combination that we will get. So that's what the fundamental theorem of arithmetic states. Okay, so based on this prime factorization method, we can find the HCF and LCM, right, of the numbers. So let's look at those. Okay, HCF. What is HCF? In your earlier classes, we would have learned. What is HCF, guys? So highest common factor. HCF is the highest common factor. LCM is the least common multiplier. Okay, so by the definition, what HCF means, the product of smallest power of each common prime factor in the numbers. Let's say I need to find the HCF of two numbers. Let's take any one example from your textbook. Okay, so let's find the HCF of two numbers. Let those numbers be 26 and 91. No, let's take a good example. Okay, 96 and 404. Okay, HCF of 96 and 404. So how to find the HCF? First, we need to write these numbers into prime factors, and then what the definition says, product of the smallest power of each common prime factor in the numbers. So first let's write the prime factors of both the numbers. Let's write for 96 and also let's write for 404. So 96 I can write with 2, right? 2 into 2 4's 8 and then 16 means 2 into 48 times. Then 2 into, I can further divide with 2. So 2 into 2 2's and 2 4's, right? Then 2 into 2 into 2 into 12, right? So 2 into 2 into 2 into 12 I can write as 2 into 6. So 2 into 2 into 2 into 2, 6 I can write as 2 into 3. This is where I need to stop because now I have all the prime numbers. Now, what is the power? How many times 2 we have? 1, 2, 3, 4, 5. So 2 power 5 into 3. These are the prime factors for number 96. Let's look at 404. So 2 into 2 2's 0 and 2 2's, right? And then 2 into 101. Okay, so 101 cannot be divided with 2. So let's look at maybe 3. 3 3's 9. No, it will not go with 3 also. Let's look at 4. No, sorry, 4 is not a prime number. So let's look at 5. No, 7. 7 7 ones and 31. No, it will not go with 7 also. 9, no. 11, no. I think that's where we need to stop. So 101 is a prime number. It is not divisible by any other number. It does not have any factors. So the 404 I can write as 2 square into 101. So these are the prime factors for this number. Now, what is HCF? So the HCF of these two, 96 and 404, is the product of the smallest power of each common prime factor in the number. So what is the common prime factor here? 2 is the common prime factor. Now, product of the smallest power of each common factor. So I have only one common factor, which is 2, and I should take the smallest factor, smallest power, that is 2 square. So that means HCF of these numbers is 4. That's the highest common factor. Understood? So that's how we can find the HCF if using the prime factorization method. So both the numbers, two numbers are given. You need to write those numbers into prime factors and then need to see how many common are there. Each common element you need to multiply with their lowest power. Here I have only 1. For example, I have 3 here also, then into 3 I should 2. That's how we can find the HCF. Understood? Okay, now let's move on to the next one. What is LCM? LCM is the product of the greatest power of each prime factor involved in the numbers. So for example, the earlier scenario, right? In this case, let's find the LCM. So LCM of same numbers, LCM of 96 and 404. So I don't need to write the factors again because I have written here. So 96 is 2 power 5 into 3, and here 2 power 2 into 101, right? So I'll directly write those. So 96 equal to 2 power 5 into 3, and then 404 equal to 2 square into 101. Now I have the prime factors. Now what is LCM? The product of the greatest power, highest power here. In HCF, it was lowest power. Here it is greatest power of each prime factor involved in the number. So how many prime factors are involved here? 2, 3, and 101. So 2 into 3 into 101 we need to do. And now we need to take highest power. Highest power here for 2, I have 2 power 5 and 2 square. So I should take 2 power 5. Understood? And for 3, there is only 1. So 3 power 1 into 101. So if I do the product, that is what the LCM of these numbers. Understood? So we'll take some simple example, right? So this will come as 9696. So this is the LCM of these two numbers. Now let's take another example, okay? Let's take another example from your textbook, that is 510 and 92. Okay, so LCM of 510 comma 92. Now first what we need to do, first write the prime factors of 510 and 92. So let's take 510. So what is 510? 510 I'll start with let's start with 2. So 2 into 2 2's 4, then 11, 2 5's 10, then 10, 2 5, so 255. So 2 into, then I'll start with 5, 5 5's and 5 1's. Then 2 into 5 into, then I'll start with 3. 51 I can write as 3 into 3 1's and 3 17's. 3 7's, right? So this is basically 2 into 5 into 3 into 17. That is 510. Now let's write the prime factors for 92. So 92 I can write as 2 into 46, right? Then 2 into 23. Okay, so I don't think we have any factors for 23. So 23 is also a prime number, so I can leave there. Okay, so that is 92. Now let's do LCM first, right? So the LCM of 5, 10, 92 is, first you write the all prime factors. So I have 2 into 5 into 3 into 17 into 23, right? And then I need to take highest power. For 2, it is 2 square. So I should take 2 square into 5 into 3 into 17 into 23. That is the LCM of these two. And then what is HCF? The HCF of these two, 5, 10, and 92 is the product of the, what are the common factors here? Only 2 is there. For 2, the lowest power is 2 power 1. So HCF is 2. So the highest common factor for this is 2, and the lowest, the least common multiplier is 2 square. So this is like, yeah, if you multiply that, you'll get the answer. That's the LCM. Okay. So if you want, we can take some simple numbers and we can do that as well. So let's do LCM and HCF for 6 and 20, right? So the LCM for 6, 20. So write factors for 6 first. So 6 can be 2 into 3. And then write for 20. So 20 can be 2 into 10. Then 2 into 5. That means I can write this as 2 square into 5. This is 2 into 3. Now, what is HCF? The HCF of 6, 20 is the product of how many common is there? 2, and yeah, 2 power 1. So 2 is the HCF. And then LCM is, LCM of 6, 20 is, what is the LCM of 6, 20? The product of the greatest power of all the prime factors. So which are all the prime factors? We have 2 into 3 into 5 we have. And then for 2, we have 2 square as the greatest power. So 2 square into 3 into 5. That means 4, 4, 3 is 12, 12, 5, 60. So 60 is the LCM for 6, 20. Understood? Okay. So this is how we can find the HCF and LCM for given numbers using prime factorization method. Now, there is a relation. The two prime number, the two numbers, the composite numbers, right? The two numbers, the product of the two numbers should be equal to the HCF into LCM. For example, let's consider any of these, right? So in this example, the LCM of 6, 20, right? So the LCM of 6, 20, that means A and B are was 60, right? And then what was the HCF? HCF of 6, 20 was 2. Now, if you, with this, here A is 6 and B is 20. Then what is A into B? A into B is 6 into 20, which is 120. Now, LCM into HCF equal to the product of the numbers. For example, if you know what is LCM into 60 into 2, that is also 120. So this formula we can use if we know the numbers and if you know either LCM or HCF. So what you need to do is multiply those two numbers. Understood? And then divide with whatever you know. If you know the LCM, divide with LCM, you'll get HCF. So from this, we can write the HCF equal to A into B by LCM. That's one thing. Or if you know, if you know HCF, then LCM you can find by the product of the numbers by HCF. Understood? So that's how this formula will be helpful. So you don't need to find both LCM and HCF. You multiply the numbers and divide with whatever you know, then you will get the other value, LCM or HCF. Okay. Now, yeah, given that HCF of these two numbers is 9, find LCM. Okay. So our formula is there, right? So what was our formula? LCM into HCF equal to the product of the numbers. So we know the HCF of this is, so LCM is A into B by HCF. So what is A here? 306 into, so these are A and B, right? These numbers are A and B. 306 into 657 by 9. So check with 9, which so 9 ones, 9 threes 27, then 36, 9 fours 36. So the LCM is 34 into 657. So whatever the value you get, that will be your LCM. Okay. So these type of problems can also be asked. Now, yeah. So that's about today's session. So let's do a quick recap here, right? So the quick recap is, in today's session, what we learned about what is the number system, right? The rational numbers, integers, whole numbers, natural numbers, all that stuff. And then how to write the prime factors of a given number. And then what fundamental theorem states is every composite number can be expressed or factorized as a product of primes. And this factorization is unique, and the prime factors can be in any order, as what I showed here. And then we learned about what is HCF. HCF is what? Product of the smallest power of each common prime factor in the number. So what you need to do, first you need to write the prime factors of each number and then see which are the common prime factors, and you need to multiply those common prime factors with their lowest power. Okay, so that's HCF. So LCM is the product of the greatest power of each prime factor involved in the number. So if two is there in both the numbers, then you take two only once. Okay, so 2 into the remaining prime factors with their greatest power, whichever we have common. For example, we have 2 and 2 square here, so we'll take 2 square into the remaining prime factors. Okay, that's HCF. And then we also learned HCF into LCM is nothing but the product of those two numbers, A into B, and this is applicable only for two integers. If it is a three numbers, then you cannot use this formula. This is applicable for only two numbers. Okay, so using that, we have also done that. So that's all. So that's all for today's session. So I hope you all understood the topic, and I'll see you next time. If you have any queries, you can reach me on my Urban Pro profile. Thank you.